So yeah, that is a good criticism about the directions. So should include a discussion of slope with regard to each graph, but you are supposed to be linking graph A and graph B. So how are you going to talk about the slope of graph A without linking it to graph B unless you also talk about where graph B is positive and negative? So
What are okay? Go ahead.
so
Sorry
I
to
think the
interrupt.
grading was I was lenient on the grading this time, and so I meant to accept if you only talked about the zeros, I think I accepted that. Um,
Uh,
but
well,
in future takes of this question, you need to be more thorough. Yeah, go ahead.
so I got in negatives because I wrote only about the slope. I don't
Okay,
know.
let's set up an appointment. You and I can talk at some time outside of class, or
Sure,
maybe we'll have some
that's
time
fine.
in class today. Yeah, no, I'm definitely willing to have a conversation with you about the grading.
Do you have an office hour today, or
I don't. Just make sure you touch base with me at the end of class today, and we'll get something set up.
sure?
Okay. So I just want to say for future reference, you want to show where the increasing graph overlaps in the exact same x values as a positive graph to get that connection between f and f prime. Okay. And then one other piece, um, the derivative of graph C is none. And a lot of people just gave the answer of, well, the other two already have their derivatives, so graph C's derivative can't be listed. So what I want to encourage you to do is think about the standards. So remember this, we're doing standards-based grading this semester. The standard is I can use information about f, f prime, and or f double prime to identify and or draw accurate graphs of other functions. So you want to be thinking about this graphically, right? Does saying like process of elimination support demonstrating your knowledge of that standard? Or would it be better to say something like graph C is always increasing, therefore its derivative would have to be always positive, but no graph is always positive, therefore graph C's derivative can't be here. So which answer does a better job of demonstrating your mastery of the content? Does that kind of make sense? That's asking a lot of you to think on that higher level. But sometimes you can use the wording of the standard to maybe help you give a better answer. Are your answers supporting the standard? And again, that's asking for a very high level, but if the student is like, you've got enough time to think that deeply about things, that's something you should be thinking of. Do you have questions on how to interpret the standards or how to think about, is your answer supporting the standard? Does that make sense or does that seem drastically unfair? Let me know something about that. And again, I get that's a very high expectation, but use the standard wording to help you kind of inform how to write your answer. So again, the idea is that graph C is always increasing, so C's derivative would have to be always positive, but graph A and graph B and graph C have negative values. So neither one of those could be the derivative of C. That would be an answer that does a better job of convincing me that you understand the relationships between f and f prime. Um, Questions about this or ready to move on to D4? Give me a Y in the chat window if you're ready to move on. Okay. D4 was asking for kind of the details that we just went over on the intervals where A is increasing, decreasing, that type of thing. I want to talk about D4 part 5, which said which graph has a second derivative that must always be positive. And how do you know? So the way to think about this, or a way to think about this, is what characteristic does the second derivative tell us about a function graphically? So I'm giving you information about the second derivative. What information am I giving you about the parent function? Like, what does the second derivative tell me about the shape of the parent function? Let me know in the chat window. And if you don't know, say I don't know, so I kind of know, are you being quiet? Are you checked out? Do I need to say more about this? Are you breathing? Yeah, so we got a couple answers there about concavity. Great. The second derivative tells us about concavity of the parent function. So if the second derivative is positive, the parent function is opening upward or concave up. If the second derivative is negative, the parent function is kind of concave down or opening downward. Okay, so if the question is asking which graph has a second derivative that must always be positive, well, if we take a look at graph A, is that highlighted stretch concave up or concave down? Let me know in the chat window. You can type up or down. Is the highlighted part of graph A concave up or concave down? It's concave down, opening downwards. So is the second derivative there positive or negative? Is the second derivative of A positive or negative? It's negative, okay? So A would not be a graph that fits the characteristic. If we take a look at graph C, that highlighted stretch, is that concave up or concave down? Okay, but if we take a look at graph B, always concave up, right? Yeah, so for part 5 on question 4, which graph has a second derivative that must always be positive? Well, which graph is always concave up? Graph B is always concave up, therefore graph B always has a positive second derivative. So get in the habit of thinking about parent function gives you output values. First derivative gives you slope, increase, decrease. Second derivative gives you concave up or concave down. Okay, so make sure you get really comfortable translating all of those things. Any other questions for me on D4 or D3, or give me a Y if you're ready to move on. One thing just to point out, there are a few students who changed their intervals when they were telling me where the function was increasing or decreasing. They'd say like 0.4 to 1.5 on one part of the problem, and they changed it to 0.3 to like 1.2. You want to make sure that you're being consistent. If you tell me the first derivative is positive on an interval, then your function is increasing on that same interval. So be a little, pay attention to your consistency there. Okay. D5, woof, man, this is a fun one, yeah? So D5 is the definition of derivative, like using it, okay? So we had x squared minus 3 absolute value of x. And we wanted to know, does f prime of 0 exist? And the biggest issues that I saw with this while grading, it's my least favorite issue, but it's the one I have to talk about all the time, which is notation. Okay. Another issue was 0 over 0 means does not exist. Like, we don't want to do that. 0 over 0 should tell you I need to do more work. And so what is the strategy to do that? Typically, or in this case, we needed to switch to one-sided limits. Okay, and then there are just some issues with actually computing the limit. So those are some of the big issues to worry about. So if we're going to set this up as f prime of 0, we're going to do f of 0 plus h minus f of 0 all over h, except that that's not what we're doing. Been looking at your work too long, so I forget that. What do I need to put in there? What's missing? What's missing from this derivative statement? What did I just make room for? Awesome. So what I wrote down was just the average rate of change. And if I want the derivative, I need to put the limit as h goes to 0. And that whole thing will give me the instantaneous rate of change. Okay, and so then we can go ahead, limit as h approaches 0. And we could take 0 plus h and plug that in for x in both places. So I get 0 plus h squared minus 3 times the absolute value of 0 plus h minus 0 squared minus 3 times the absolute value of 0 all over h. Okay, so let's simplify now. Limit as h approaches 0, we're going to end up with an h squared minus 3 absolute value of h. All of f of 0 is just 0 divided by h. So what questions do you have getting to this step? And if you have no questions, thank you for letting me know that. I really appreciate it. And I love fun typos, so go ahead and type none in the most misspelled way you possibly can, but let me still know what it is, right? Okay, so now at this stage, if we try to plug and chug, if we were to try plugging and chugging, we would get 0 over 0. And some of you stopped here and said, oh, it does not exist. No, we have spent weeks learning how to deal with limits where you have 0 over 0. Okay, we need to use algebra to help restructure this to see if we really do have a case of does not exist, or maybe the whole thing is 0, or maybe the whole thing is infinity. Like, we need to do more work. So this should tell you, do more work, investigate, explore, get curious, get creative. Yeah, we need to figure out how to get h out from the numerator so we can divide. And our problem is that h is locked up in this absolute value sign. So what we can do is we can say, well, I need to get rid of the absolute value signs. How do we get rid of absolute values? What's our strategy for dealing with absolute values? How do I kind of sidestep this issue? It's kind of a two-prong approach. Yeah, we rewrite absolute value of h as a piecewise defined function, and then we do two one-sided limits. Beautiful, great. So we split this into positive h and negative h. We have positive h if h is greater than or equal to 0. It doesn't matter where you put the equal sign. I'm going with the top one today, okay? And so then we are going to have one of the limits now becomes the limit as h approaches 0 from the right. And then the other one, we can do limit as h approaches 0 from the left. Okay, so as we do 0 from the right, we're going to keep the h squared minus 3. But what are we replacing absolute value of h with? So limit as h approaches 0 from the right, we're going to replace absolute value of h with what? Positive h or negative h? Let me know in the chat window. What do I write here? Positive h or negative h? Yep, I'm going to use the positive h. Okay? Because h is approaching 0 from the right, so h is slightly greater than 0, so that tells me to use the positive h. Okay? And if we continue on with this limit, now we can factor. So limit as h approaches 0 from the right, we can factor an h out of the numerator. And now they can cancel. Now we're left with h minus 3. Now we can plug and chug. We get 0 minus 3 equals minus 3. Type a W if you want me to slow down, a Q if you have a question, or a Y if you're ready for me to move on to the next limit. Okay, so now if we're coming from the left, do I replace absolute value of h with, so coming from the left, I use positive h or negative h. Keep the h squared minus 3 times something. What am I going to, let me know in the chat window, what goes inside those parentheses? H is approaching 0 from the left. So we are to the left of 0, so we have negative values. So I'm going to use the negative definition, which says negative h. And again, we can now factor out an h in the numerator. We have h squared. No, factoring out, Hillary. Do we have a minus or a plus 3? Let me know in the chat window, minus sign or plus sign. Is that a minus sign or a plus sign in front of the 3? It's a positive because we have those two negatives. The h's cancel. Now I can plug and chug. 0 plus 3 leaves me with a. I don't think I've had my brain try to draw the answer box before the answer. Oh, well, fun times. Okay, so now I've fully investigated the limit from the left and the right. What is my conclusion? What do I know about the two-sided limit? Negative 3 does not equal 3. Therefore, f prime of 0 does not exist. So we do end up with does not exist, but now we have a solid reason we can point to as to why. So what I need you to do is I need you to pay attention to the notation. A lot of students were dropping notation or not telling me they were doing limits. If you are not doing a limit sign, these two fractions are not the same. You can't cancel the h's unless you tell me h cannot be 0. So you have to have the limit sign. This cancellation step is illegal unless you're doing a limit. If you need to get rid of the absolute value, you have to do piecewise, and that means you need two one-sided limits. And you can't just give up at 0 over 0. You have to do more work. What questions do you have for me on this? Is this helpful? Did this help some of you? So I think we're making good progress. It's starting to get the ideas down. I just want to keep nudging you. I want to nudge you into the direction of how can you do better? How can you think more deeply about this? How can you be more careful? Okay, I have one more little rant, and then I'm going to be more specific with your questions. So give me a Y in the chat window if you're ready to move on to the next topic, a W if you want me to just slow down, Q if you want to type a question in. Okay, just real quick, if we're doing power functions, remember that they look like a number times x with a number in the exponent. And if you're going to take the derivative, you can use the power rule. But you first want to write your power functions as a painfully obvious power function. So if we see something like the square root of 4x cubed, that is not a painfully obvious power function. How do we make this a painfully obvious power function? So the most common mistake I saw is people just kind of put the 4 on the outside of the square root, but the 4 is still under the square root. Okay? But if I want to make this a painfully obvious power function, I want to have just some number out in front, then x, then a number. So I don't want to have 4x cubed inside. That's a great intermediate step. I love what you wrote there in the chat window. Thank you for that. 4x cubed all to the 1/2. That's a great first step. But I want to move toward number, x, number in the exponent. Okay, so in the chat window, how do I rewrite this as number, x, number? What are those numbers? What is my coefficient and what is my exponent? Okay, we've got some good ideas there, so let's go ahead and explore this a little bit. So yeah, the square root of 4 is 2. Okay, square root of x is the same thing as x to the 1/2. So we've got good pieces in here. Now, I only want one number in the exponent. I only want one exponent. I don't want x cubed to the 1/2. And don't forget, you got to get that 4 is going to be a 2 because the 4 was inside the square root. So it's not going to be 4 times x, it's going to be 2 times x. So make sure you get that. Yeah, good. And then we have a 1/2 from the square root, and we have a 3 from the original exponent. So 1/2 times 3 is 3/2. So I have not done a derivative. I've only done algebra. This is only algebra. But this is how you rewrite something like this as a painfully obvious power function. And now we could take the derivative. And now we could use the power rule. And so now we would get 2 times 3 halves x to the 3 halves minus 1, which we see the same thing as 2 halves. So we get 3x to the 1/2. Yeah, question.
So is it wrong or is it right to write it as 4 multiplied by x to the third all over the all raised to the power of 1/2? Is it wrong or is it just more complicated?
So as of today, you do not know how to take the derivative of this.
Okay.
So if I want to ask you to take the derivative, you have to rewrite it as a painfully obvious power function and use the power rule. This is a composition of functions. This is a 4 times x to the 1/3 stuffed inside a square root. We're going to learn about how to take the derivative of composition of functions tomorrow.
Okay.
Yeah, so is it wrong? Well, if you're going to use the power rule, you can't use the power rule at this stage.
Okay, I see.
Yeah.
Thank you.
Other questions? And please double, if you don't think it is 3x, wait, I can get my confidence boost because I have the answer key in front of me. So you could also rewrite this then as 3x to the 3 times the square root of x. You could simplify it if you wanted to. In general, I don't recommend simplifying on basic derivative problems because you might make an algebra mistake and then I have to grade that and that'll put me in a bad mood. And if I'm in a bad mood, that's bad news for you. Okay, real quick, the previous question, if you have 2 over 3 t to the 1/2, how do you rewrite that as a painfully obvious power function? I want a number, I want a t, and I want a number. So we'll do one more example and then we'll move on to something else. How do we rewrite 2 divided by quantity 3t to the 1/2 as a painfully obvious power function? You can let me know this in the chat window. Got a couple of ideas here. So one intermediate step I might take is I might take the coefficients and separate them from the variable pieces. That maybe helps me kind of pull out the variable parts and the coefficient parts so I don't make a silly mistake. Because I tend to make silly mistakes. So I have all these like, do this piece here, do this piece here to try to help mitigate that. So yeah, the coefficient would definitely end up being a 2/3. Awesome. And then, yeah, and we don't want to just do like 2t to the negative 1/2 all divided by 3. We want to pull all of the coefficient pieces out in front of t. And the reason I'm doing this is so that when we're taking derivatives that are really nasty, so like if we were to have 2 over 3t to the 1/2 times sine of t plus e to the t all over 32t plus t cubed, like if we're doing a derivative like this, you don't want to spend 15 minutes on the first part. You want to just rewrite it as a painfully obvious power function so you can move on with the other rules. So this is why I'm harping on this, because if you're trying to do a complicated rule and you're still using the quotient rule on something like this, it's gonna get ugly fast. So my goal is to get you to simplify so that you can take the derivative quickly and efficiently. Okay, so the exponent was a 1/2 in the denominator. To pull that into the numerator, you just make it negative. So 2/3 t to the negative 1/2. And then you're ready to take the derivative. So we haven't taken the derivative, we've just rewritten this as a painfully obvious power function. What other questions do you have for me right now? So notation was a huge issue, as it always is. Like you know that this is my thing that I'm always talking about. So double check, did you really mean to use the equal sign? If you're telling me that you've taken the derivative, every single term needs to be derived. It can't be an intermediate step, right?